In this lesson, I'll be explaining to you about Venn diagrams. Let's talk about what a Venn diagram is. It is a diagram of circles used for grouping items into categories. So if you have category A and category B, there are items which can be put into this section of a circle, this section of a circle, and also the middle section of a circle. Now let's talk about items that are common to both of them. So items common to two or more categories are placed in the intersection of the circles. So just like how I explained before, the middle part here is an intersection of A and B. So if a question involves satisfy conditions A and B, then that means that this is put in the middle of them. But if it says A or B, which means that it can be A only, it can be B only, or it could be both. That means that everything here is colored in. Okay, so it involves all the numbers that will be put into these Venn diagram. Now let's talk about mutually exclusive events. So the way this works is that if there are two types of conditions that have no overlap whatsoever, and have nothing in common at all, okay, then the circles will be separate like how we've done here in the rectangle. Okay? Let's look at all these concepts in an example. This Venn diagram shows the results of a survey on how people travel to work, car, bus, or train. So evidently, you can see that some people only take the car, or only take the bus, or only take the train, and that's resembled by these parts. So that's only car, only a bus, and only train. Okay? Now the people in the middle here would take all three of them because it's the intersection of all circles. The people here would take the car and the train. Okay? Whereas the people here take the bus and the train only, and the people here take the car and the bus only. Right. So how many people participated in the survey? Well, to do this question, we would have to add up all the numbers inside the circle. So once you add it up, you do get 100 people. Okay. Now for question B, how many people used all three methods, car, bus, and train? Give an explanation on how this might happen. So we said the intersection of all three circles, the region where they all overlap is that center number, which is 5. So we're going to say 5 people for question B. But the reason why some people might take all three of them is because a person could maybe drive to the station, park their car there, then catch the train to work, and then catch the bus to work from whatever station it is. Might be a central station. Okay? Question C. Calculate the probability of selecting a person from this survey who travels by car only or bus only. So car only resembles the part of the circle here that doesn't overlap with the other two circles. So that's 27. Bus only, which is this part of the circle, involves a section of that circle which doesn't overlap with the other parts of circles. So that's the 11 here. So 11 and 27, they add together to give you 38. Okay, and this is a total of 38 out of the 100 people who are surveyed. Part 2, which is car and train, okay. The people who catch the car and the train, well, that's the car's circles here, the train circles here. The overlapping bit of those two circles is here. So these people, okay, would catch the car and train, and this includes the people who also catch the bus, okay. So this doesn't tell you whether they catch the bus or not, but it includes both of them, okay. So you can assume that this is also ticked in, as well as the people who only catch the car and train, all right. A simple way of actually thinking about this is that if all these people are seen in a room, who would put their hands up if we asked who catches a car and a train? Okay, then these people will put their hands up, right? But if I say now car and train only, Okay, by the way, the answer is 25 of 100. What if I say car and train only? Okay, to that audience. Then that would mean that I'm looking at that 20 there only. That's 20 out of 100. Now, what if I say bus and not train? Okay, so the people who catch the bus are belonging to this circle, but if I don't want the people who catch the train, so not the 5 and not the 4, which is part of that train circle, then that only includes these two numbers, 12 and 11, which add together to give you 23 out of 100. Right, for question D. A person is chosen at random from the people who travel by car or train only, but not by bus. Okay, let's have a look at that. So car is here, and train only, but not by bus. Okay, so it's not by bus. That means we don't want to include this circle here, which means it doesn't include that 5 there. Okay, so the people who travel by car or train only, but not the bus, actually involves nothing to do with this circle. So that's nothing to do with this, sorry. Nothing to do with this and that. Okay, so how many do we actually total up? The people who catch the car or train only but not bus will be these 3 numbers. So if we add them all together, we will get 68. So out of the 68, it is saying, what is the probability that the person travels by car only? So that's this number. That means we get 27 out of 68. Now for question E, if 110 people actually participate in the survey, what extra information will be needed in the diagram? So remember how earlier in question A, we had 100 people in total. These 100 people belong to each category of catching the car, bus, and train. But just by looking at the total number of people here, there's an extra 10 compared to 100. So where does that go? That goes on the outside, okay? So people might walk to work, or people might, catch or ride a bike to work, or something else, okay? Now let's have a look at the next example. Example 6. So a survey of 100 students at Ramavale College showed that 61 students had dark hair, 42 students had brown eyes, and 20 students had both dark hair and brown eyes. Okay, so we can see evidently that there are 2 categories, one which is to do with dark hair, and I'm just going to take the first letter of each word and capitalize it, make it DH for dark hair, and then brown eyes, so that's BE. So we want to represent this on a Venn diagram, which I have started here, right? Now, the thing is, when you put any kind of information into a Venn diagram, I would recommend putting all the information that is to do with the overlapping part, okay? So the ones that have dark hair and brown eyes, or put a number outside, which sometimes they might have, and that refers to, in this case, not having dark hair and not having brown eyes, okay? So in the center here, where that belongs to students who have both dark hair and brown eyes, this would involve 20 of these students. So we're going to write 20 there. Now, let's have a look at what we can put in this part of the Venn diagram. It says here that 61 students had dark hair. So if I have a look at this circle, okay, this should include students with only dark hair and students with dark hair, but also with brown eyes, okay? So, if it includes both of those types of people, this all includes 61 students. So if I've counted 20 students, the remaining students that I need to calculate would be 61 minus 20 to give that number there. Now that number is simply number 41. Okay? Now BE, which is the number of students with brown eyes, okay, that includes 42 of them. So 42 of them had brown eyes, right? That means 42 includes all these students inside the circle. So if we counted 20 already, this number here would be 42 minus 20, which is 22 students. Okay? Now let's total up this up together. If I add all these numbers up together, I do get a total of 80, no, is it 83? Let me just double check. Yep, it is 83 students, right? So if there's 83 students, then what goes on the outside? Then, well, we've got 100 students in total, right? So if we get 100 minus these three numbers, which was 83, then we should get a number 17 outside. So these 17 students do not have dark hair, or they don't even have any brown eyes at all. All right, let's have a look at B. How many students have brown eyes or dark hair, but not both? So this means we're looking at people with brown eyes or dark hair. That resembles everything here, but because we don't want both of them, okay, so out of everything I'm coloring in, okay, right here, I don't want the middle part, okay, which means that all I have to include is just this part, okay, which is the 41 here, as well as the 22 there, okay. So that means I would count 63 students in total. Now, what is the probability of selecting from this group a student with dark hair? Okay, so if it says probability of dark hair, it doesn't matter if they only have dark hair or if they have dark hair and brown eyes. It doesn't matter. It's generally saying, look at the circle that says dark hair. So that's 61 students, but that's out of 100. Now, what if we look at students with dark hair and brown eyes? So if it says and, okay, this means that it has to satisfy both conditions, which means we look at the center. So that will be 20 out of 100. For part 3, with dark hair or brown eyes, this includes everything within the two circles. This includes both and the number of students who have only dark hair and only students with brown eyes. So if you add those three numbers together, you should get, I believe it was 83. Okay, so the answer for this one would be 83 students out of 100 satisfy that condition. Now, if you have neither dark hair nor brown eyes, so you don't have either of them, that includes just the people here on the outside of those two circles, which is 17 out of 100.